Hi, today we're going to be taking a little bit of a deeper dive into SQL and multi-value data structures as they relate to the EDA product. If you haven't already viewed the introduction to EDA video, you may want to go back and check that out first before we get into this one, because this is a little bit of a deeper dive. I'm Tim Snyder. I'm the CSE manager with Rocket Software, responsible for delivery services for our customers' multi-value products. Here's some links you might find useful if you'd like to follow along with the demos. We have the XDemo account for Unidata and Universe, and we have it for Windows and Linux. There's also the EDA Schema Manager, which is used quite extensively in these EDA demos, and the EDA CheckX utility, which we'll be using to scan for and help you repair dirty data. So when we talk about EDA, we talk about data types. It's very important to make sure that things are typed correctly so that they show up properly in the SQL environment. To make that easy, uh, EDA uses the U2 dictionary items to make it a simple matter of just mapping things to SQL. The dictionaries give information about the type and the format of the data that you're going to be mapping. And then the EDA Schema Manager makes some pretty intelligent choices about mapping things. But if something isn't quite what you're looking for, it can easily be overridden. So some examples, if we have a date or a time field in the U2 database, it would be mapped to a date or a time or a date time field in SQL, depending on the SQL database. They all have their own little approaches for that. If you have a numeric field, it will be mapped to an integer, a float, or a real, again, depending on the SQL database that you're going to be working with. And text fields are created as a varchar, variable length character. It defaults to a length double the field size defined in the dictionary. So usually that provides you pretty good buffer between the way the field is defined and the way the data actually appears. But you may need to increase it even more, and that's something you can easily do with the Schema Manager. So it's really important to have proper dictionary definitions. If your dictionaries are really clean and really well defined, the database, you're going to have a pretty easy job mapping things for SQL. So you really want to keep your dictionaries clean. The better your items are, the better EDA will be able to make the right choices for mapping your files. You really want to make sure that your dictionary items establish whether something is a single value or a multi-value. If that's not properly defined, things aren't going to work very well because it's going to see something that might contain multi-values and it's defined as a single value, and then that gets pretty ugly when you get it over SQL. Within Unidata, you can define dictionary items as containing sub-values. Within Universe, you can only define whether it's a single value or a multi-value. However, with EDA, you can address that. It takes an extra step in setting up your definitions for the file, but it can be done. If your dictionaries don't have proper conversion types, you're going to also have a problem there because EDA is not going to be able to make the correct decisions about how to set up the appropriate fields, the columns in your SQL database. If you have associated multi-values defined, that's going to make things a whole lot smoother for you because any multi-value fields that are associated will appear in a single table, with them all the fields included there. If you have multi-values that are not associated, each one will appear in its own SQL table, and that can make things pretty ugly for the SQL folks that need to try and join all that together on the back end. But we're going to do a quick demo. We're going to follow through with the U2 file. We're going to show its dictionaries, and then we're going to map it for SQL. We're going to show the same information before and after the mapping, or that we're going to show it on the U2 side and on the SQL side. And then you'll be able to see the relationship between the main table and its affiliated multi-valued tables. And we'll look at the contents of the main table and all the data, all the multi-values that apply to it. And we'll also talk about a row number and the way that this is handled, the way that SQL will take this multi-valued stuff and put it into a format that's easily usable within first normal form SQL.
So let's take a look at this files dictionary. This is for the members file, which we've already converted for EDA use. So we can see it has some fields in here, last name and surname. We had already discussed those previously. We have multiple definitions for the same attribute. We have a date field here for the birth date. We have some associated fields that are going to tie together. And we have all this information residing in the dictionary. So let's take a look at how that correlates over into SQL Server. So we have all the single valued fields residing in members.members. So let's take a look at the top 1,000 rows here. So here we see all this information that we've populated, and this is all the single valued information that we have mapped for SQL use. And now if we come over and we look at some of these multi-valued associations, we have this card info. So there's a table over here called card info multi-valued. And let's go ahead and take a look at that. So we can see here, it lists the ID, but it also lists a multi-value position. So for record 1, that means that we have 3 multi-values, numbered 1, 2, and 3, and here's the information that corresponds to those. If I come back over to my U2 session, and I would list members and card info, it will show me the same information. So here we have members file, and it's sorted by the member ID. And so we have key 0001, which correlates over here, 001, and then multi-value 1, 2, and 3. So the query language doesn't list the multi-value numbers. It never has. It's acting the same way as it always has. But it shows all this information line by line, and that's exactly what we see over here. So the same credit card number that we had over here resides over here. American Express, the same expiration date, and so forth. And so that's how things get tied together between the single valued and the multi-valued entries, and how it creates a separate table for each of the multi-valued information. If we have the address field, that is multi-valued, but it's not associated, that becomes its own table. So something you want to really pay close attention to, and if you're not exploiting associations in your dictionaries, you may want to consider doing that before embarking on an EDA endeavor, because if you can associate those fields, they will be wrapped together in a single table rather than creating a separate table for each one of them, and that obviously is not ideal from the standpoint of performance, and certainly it's not going to make life very easy on whoever has to map this stuff into SQL.
So there are some other multi-value university courses you might want to check out, particularly the ones that are related to EDA. So by all means, check those out, and we will catch you in the next video.